Hello students. So today we'll be doing our introductions to robotics using CIROS, right? So before we get started, I want to show you how to configure the robot, right? So first, when you open CIROS, you're gonna get something like this, right? And then you're gonna go to File, and then New, and then you're gonna select MPS Station, right? And then here, it's where you're gonna save the file as whatever you want, right? And then it's gonna load, and then after it loads, you're gonna get modeling libraries on the side, right? And then from then on, you go to Festo MPS, and then you drop down, and then you select robot assembly, not robot assembly version C or robot assembly, yeah, whatnot, just robot assembly, right? So we're gonna be programming this robot, right? So and then you load this robot, and then you close your modeling library, right? And then if you want to move in a linear direction, X and Y, you select this, and then when you want to rotate or move using angles, you select the second one. And then when you want to zoom in or zoom out, you use your mouse roll or mouse wheel, right? So now this is the robot you want to be programming, right? So now what you should do, right? You should go to programming, and then go to teaching, right? So you're gonna put teaching on this side, and then on here on the teaching, you're gonna select katas and coordinates, right? And then now you're gonna go to programming again. This time you're gonna go to project management, and then under project management, you're gonna right click, and then you're gonna create a new project, right? So the programming language that we're gonna be using for our robot, it's Melfa Basic 5, right? So you're gonna select this language, right? So be careful when you select, because there's Melfa 3, 4, 5. We'll be using 5, right? And then you name your project. So let's say I name this like robotics practice, right? And then I press OK, right? So now I get something like this, right? So now you also get like this after you've created your project files, right? So you right click on files, and then you add new, and then you add your program, right? So your program is the tab that you want to be using to write your code, right? And then from then on, after you've added your program list, you're gonna right click, and then now you're gonna add your positions list, right? So this is where you'll be putting your position, right? I'll explain more in details about what does this mean, right? But now just load it. So now to ensure that you are controlling the robot, right? So you click on here, right? And make sure that like this is the robot you have selected, and then under here, your project, it's this, right? So if it's like this, your code won't run because there's no project being selected. So now you have to make sure that you select this, right? And then you should also activate this, right? I'll also explain to you what it does, right? But in simple context, like it sort of like indicates which part of your code is running, right? So now, before we continue, I want us to go over the guide, right? So the first few pages are for the configuration, right? As I was indicating to you, right? As I was indicating to you, this is for configuring the robot, right? And then here, these are also the shortcuts that I went over, and these ones as well, like also went over them, but you can also look at them for resetting, compiling a project and whatnot, right? So it's a good advantage, like if you know the shortcut, but it's not compulsory for you to know them, right? So, okay. So let's start, right? So now here, you have what you call your teach in, right? So how this robot, so I'm just going to close project management, right? Before I continue. So now you have what you call your teach in, right? So in real life, right? How you program your robot, first you have to create positions, right? And then after you've created positions, you tell it like, and then you tell it to move to a particular position, right? So the teach in, it's used in real life. It looks like, let me see. Mitsubishi. So the teach pendant that we're using, it looks like this, right? So yes, so now you can use it to move your robot. I'm not sure if you can see in, you can use it to move your thing in different directions, right? So now like you can move it in the X, Y, you can adjust the speed. So yeah, that's like what a teach pendant is used for, right? So they use it to move the robot like in different directions, and then like from then on, those positions they become saved, and then after they're saved, that's when you write your code. Your code tells the robot where to move to now, right? So now, and then after we have defined all of the positions, we can now come here to program and tell the robot to move to this particular position, and depending on where we want it to move to, right? So now I want us to, we'll be focusing on this and this, as well as our, so if I can just reduce this and then put it here. Okay, so this is what we'll be focusing on now, right? So first, like when you program your robot, right, you need to have a position that's called home, right? So home position is sort of like after, let's say your robot is assembling workpiece, right? So let's say after it finishes assembling workpiece, it's gonna maybe drop the workpiece on the second shoot, and then after it's done, it needs to return to a position where it can await the arrival of the next part, right? So that's your home position, right? So now, like let's say I'm trying to define my home position here, right? So before I define home position, right, let me just show you how to navigate the robot to get the coordinates that you want, right? So you have your x-axis, right, which you can robot, right? And then here you have your y-axis. So if you want to move it side by side, right? And then you have your z-axis. It's for up and down, right? So this is down and then up, right? And you have this side. So this side is for you to adjust the angle, right? So let's say I'm trying to adjust the angle in the z direction. As you can see, my gripper's rotating in the other direction, right, to adjust its angle. And then here gripper's rotating in the opposite direction. And then on this side, as you can see, the robot is also rotating in this direction across the y-axis, and then goes back, and then your x, as you can see. So this is how you make the different rotational movements of the robot, right? And then if you want to reset to the position you're in, you just click on reset, and then it will go back to where it was, right? So now, let's say now, as I said, like now we have to first, the position that we first have to define, it's called the home position, right? So home position is where your robot goes back to when after it's done completing the work cycle, right? So how you do that, right? It's so home can be like whatever position that you want, but if you are given, obviously you have to what you call you have to comply to my home position, right, and use it in the test. But let's say here I want my home position to be, let's say this is what I want to be. This is my home position, right? This is the home position that I want, right? So now I can save this. I can come here and save this like as home. So I'm gonna save this position that the robot is currently in to my home position. So I just right click here and then go to insert position, right? As you can see, new position is inserted as P1, right? But you want you to right click and then you go to properties, right? And then I want us to label our home position as P100, right? So you label your home position, and then here, this is where you comment on the name of the position, right? So this commenting is very important so you can remember this is that we like what this particular position is for, right? So now I can say this is my home position, right? And then I can save this, right? So now this is my home position, right? And then now I want us to do exercise number 1, right? So if we go to exercise number 1, right, they're saying after receiving and setting up a new robot extension, you assign the task of subjecting the robot to a functional test, right? Executing the test plans for sensors in the simulation, the inputs assignments for the virtual robot control. So these are the different sensors in the robot system, but we'll be going over some of them, not all of them, right? And then here instructions are saying like the robot like grabs the workpiece and places it into the assembly block, and then it detects the material using the sensor P1 underscore R, right, on the grip, right? And then the value of the P1 underscore R sensor changes from 0 to 1 due to the workpiece being red or silver or black, right? And then they're saying after the robot places the workpiece onto the second slot of the assembly block and then returns to its initial position, right? So now, as you can see here, they're using the P1 underscore R sensor, right, which is used to detect the material composition of the workpiece, right? So they are saying like the the robot, it takes that workpiece and then moves it onto the assembly bulk. So this is the assembly bulk here, right? So it moves it into the first slot and then it tests the material composition of the workpiece. And then after that, it moves it onto the second bulk and then it goes back to its initial position. So its initial position is going to be our home push button. It's going to be our home position, this one right here, right? So for now, for the robot to grab the workpiece, for the robot to grab the workpiece, right, it has to. So let me just do this. So okay, we'll focus on that later. Right. So, but like what I was trying to say, right, it's the so yeah, as I was saying, right. So from the instructions, they are saying like we need to take the workpiece to the assembly bulk where we'll be testing its material composition, right? but like we have to. Okay, so like the sensor that's gonna be used to test material composition is the B1 underscore R sense, right? And if you look at here, right, we've been given other sensors as well, right? So now what we'll do, right? So first, I want you to observe, right? So if I press play, right, and then let's say I'm loading a silver piece, right? This is where it comes in, right? So this is where that workpiece comes in. So there's a sensor that gets triggered here to detect the availability of a workpiece. That sensor is called the part AV sensor, right? So which means in our code, now we have to define two sensors that we'll be using. And how to define the first sensor, right? Say dev, right? IO, right? And then for like the first sensor here, this one that will be detecting the availability of this workpiece, it's called, if we go here, right? So in a test, I'll give it to you like in this position, right? In this format, right? So man, this format. So this is the sensor. So it's a part AV sensor, right? So you say define IO and then part underscore AV is equals to bit, right? And then now I'm gonna go back to check for its bit number, right? So its bit number here is 2, right? So I'm gonna say bit comma 2, right? And then the second sensor, right, we'll be using is the P1 underscore R, right, which is has bit 900, right? So I'm gonna say def IO P1 underscore R, P1 underscore R is equals to bit, and then its bit number, it's 900, right? So I can just say bit 900, right? So this is the sensors that I'll be using for my code, right? So now I'm gonna call. So now how you comment, right? You put a, what is it? It's an inverted com, but the single quote, yeah, it's a quotation mark. So you put in a quotation mark, right? One quotation mark, and then let's say here you wanna say we were defining the part availability sense. You're, de you're defining the part availability sense, right? And then here, if you comment, you will say like we're defining the material composition sense. So it is very important when you write your code, every time you comment on what you are doing, so the another person who's reading your code, they know what you are trying to say or what you are trying to do, perhaps, right? So now one thing I also want you to note, right? You have to also define the speed at which the robot operates at, right? So now how you define the speed, you just say override or OVRD, and then so the speed of your robot is between 0 and it's between 1 and 10, right? 10 being the highest, right? So we don't want your robot to move too fast, right? Because it can cause safety concern, right? Let's say I want it to move at 50% of its full speed, which means at half, right? So I'm gonna move it at 5, right? So you also comment here on what you are doing. So you'll say quotation mark, one quotation mark, and then you'll say you are setting the speed of the robot system, right? So this is mainly the most important things for your robot, right? So you've defined the sensors that you'll be using and you have set the speed of the robot, right? So now if we go back to our positions, right, we have to now Now going back to the instructions, right? They said, like, going back to exercise number 1, right? They said your robot is gonna the robot is gonna grasp the workpiece and then it's gonna move it onto the assembly block, right? This is the assembly block. So it's going to move it into slot 1 where it's going to be tested for its material composition. And then after that, it's going to move to what you call the robot is going to grab the workpiece from here and then move it to here. And then it's going to go back to its home position. So we've already defined its home position, right? So now for the robot to grab the workpiece, right, it needs to it needs to move to where the workpiece is initially, right? So now it means it needs to go and collect the workpiece, right? So now we move like to collect the workpiece using the coordinates that I showed you, right? Coordinate system that I showed you. So first, since you're so we can't use our teaching without cancel. So we stop play, right? So we stop playing, right? And then now I'm gonna move down in order to go and grab my workpiece, right? And then now I have to grab it with this side, right? So now I'm gonna move closer to the robot, right? To the workpiece. So now another thing that I also want you to be aware of, right? It's the move incrementally part, right? So if you want to move in smaller increments, let's say when you are closer to the workpiece, right, you can just click on move into incremental, right? So now if you move, you can see like it's moving in smaller, in smaller, in smaller distances, right? So let's say for me, like I prefer to reduce it to 5, right? When I'm closer to the workpiece, right? So now I'm just gonna move closer to the workpiece. So I'm just gonna cancel this. So now, as you can see, I'm closer to the workpiece. I can activate my incremental moves, right? So I can move, so I don't overshoot the distance, right? So now, as you can see, like I need to grab the workpiece by this side, which means I need to rotate my Z, right? So it can face this direction, right? And then now I have to also go down, right? I think I need to go down so I can get my workpiece. So I activate move incremental, right? Then I move down the Z axis, right? And then I move, so I move to the X axis now, right? And then Y. So you keep on using these coordinates, like these arrows, right? To move to where your workpiece is, right? And then you go down, right? So now use your Z again. So you you keep on trying to move to your where your robot is, right? Where your workpiece is. So now you just keep on moving. So make sure that your robot is not penetrating your workpiece. So now, yes, I think now this is a good position. So as you can see, the work the workpiece seems like it's gonna be grabbed, right? So now what you do, right, is now you press on edge close, right? So you close your gripper, right? So your gripper, it's this, right? So it can grab the workpiece. So you press on close, right? And then now to ensure that your workpiece is gripped, right? As you can see, if I move to another position, so now the robot has grasped the workpiece, right? So now I can ensure that that position that I was in now, like it is the correct position, right? So now what I can do is that like now I have to save that position, right? So which means I'm gonna say reset, and then like, so now that's how you move to a position, right? So if let's say, as I just showed you how to, so just to preserve time, right, I'm just gonna stop the simulation, then I'm just gonna type that 270 two it is 249, right? And then this one was minus 38.3, right? And then this other one was 192.6, and then this was minus 122, and then this was 179. So now, like, this is the position where we grabbed the workpiece, right? So now, just to ensure that I save this position, right? So I'm just gonna, because we're gonna be needing this position so that every time you can grab the workpiece, right? So now I can just come here to my positions list, right? Right click and then insert that position, right? So now, after I've inserted, I'm gonna go to properties, right? And then I'm gonna rename this position to be P1, right? So when I'm commenting, I'm gonna call P1, like, so I know which position is this. I'm just gonna say collecting the workpiece, right? So this is gonna be that position. Okay, so yeah, this is how you insert your P1, right? And I'm gonna repeat again. It's very important to comment, right? So you know, like, which position did we just define, right? So now, if I can, what you call, so now since now my gripper is open, I can now close, right? After I press close, right? And then I can, let's say if I move back to my home, right? My workpiece is still grabbed, right? So I can ensure that this position that I just defined here, right? It can help us to grab the workpiece, right? So now to, if like before we go on with size one, right? So I'm just gonna write a simple code, right? So in that simple code, right, I'm gonna just take the workpiece, right? It's just a simple code. I'm gonna tell the robot to grab the workpiece and then move to home, and then it's gonna maybe delay for some time, and then it's gonna move back. It's gonna move back to. It's gonna move back to. What can I? It's gonna move back and drop the workpiece, right? So now in here, right? So I'm just gonna follow the exercise, right? So now let's say I want to grab the workpiece and return back to home, right? So since I've already defined all of this, right? So now I'm gonna reset my robot. So if I go back to my robot and then press play, insert the workpiece, right? And then I'm gonna stop, right? So now I want to tell the robot to grab the workpiece, right? So I'm just gonna close the teach in, right? Because at this point we don't need it, right? And then, which means you're gonna say here, right? First, right, to ensure that your robot is able to grab, it's able to grab the workpiece, right? We have to move it to ensure that your robot is able to grab the workpiece, right? You have to make sure that the gripper's open, right? So first line of code, you wanna say H open one, right? Which means it's gonna ensure that the gripper's open, right? So when I say you wanna comment on this, right, and you say opening the gripper, right? And then now gonna like tell the robot to collect the workpiece if the part is available, right? So we only want the robot to move to collect the workpiece in the chute only if the part is available, right? So how we do that, right, is we say while part underscore AV is equals to 0, right? And then we say while and or when, right? So now here you are creating sort of like creating a loop, right? So in that loop, you are basically saying so in that loop, you are basically saying, right, while the part available, so your part available sensor, right, it's binary, right? So if what you call if it doesn't detect a workpiece, it's gonna be 0, which is equivalent to false, right? And then if it turns on when it detects a workpiece, it's gonna become 1, right? So here we're saying while part AV is 0, which means while the part is detecting, it's not detecting a product yet. You want like you want your robot to be trapped in this loop, right? Which means it will only break this loop when part AV becomes 1, right? But regardless, like, or yeah, if it doesn't detect the workpiece, right, it will remain in its home position, right? And then when it detects the workpiece, that's when the loop will be broken, right? So now you are saying, so now if like at a point now when it detects a workpiece, right? So you're gonna say now, so when I say okay, so now we're gonna if it detects the workpiece, right, you want it to move here to collect that workpiece, right? So before we go over that, right? So when we're dealing with like this programming language, Melfa Basic 5, right? So there's two kind of moves, right? So there's MOV and then there's MVF, right? So in your MOV, right? So I'm just gonna read here what it says. So it's saying this motion generates point-to-point motion, right? Linear interpolation takes place over a fixed time interval for each angle joint from initial position to the third position, right? So they're saying this time interval is determined by the selected speed, right? So with this type of motion, all joint angles reach their end positions at the same time, and then the joint angles of the speeds can vary. And then they are saying the tool setup point travels over an intermediate or an imprecise path on this case. So this it's a very important keyword, right? So I'll explain to you what it means, right? So here with the second move, it's called MVS, right? So in MVS, they're saying this motion generates linear motion over a path, which additionally does not change the orientation of the tool setup point, right? So now here, right? So they are saying the what you call the tool setup point travels over an indeterminate or imprecise path, right? So let's say so a MOV, right? It just takes what you call in simple terms, right? It moves the robot using the shortest path method, right? So let's say, like as an example, you're trying to move the robot to maybe here, right? Somewhere we're trying to move the robot to here, right? As you can see, there are two magazines here, these things here, right? So if you use, let's say you had to use MOV, right, to move the robot to this path, right? So the robot will take the shortest path, which means it will be on a collision course with these two magazines before it reaches this position, right? And then that's why we have MVS, right? So MVS, right, we can, let's say this is our designated position, right? We can sort of like now move this robot along a horizontal path at this while we maintain this height here. The robot is gonna move from here to here, right? And then from then on, when you are here, we know there are no obstacles that the robot can hit, right? That's when we use MOV, right? Then MOV can now MOV since take the shortest path. So since now the robot will be directly above the path, our target position, that it will just move straight to the position, right? So it's very important, like understanding the difference between MVS and MOV. So MOV, you can't use when you move your robot right to a designated position. You first always have to use MVS before using MOV, because MOV you risk a danger of having collisions, right, to where you are going to, right? You can use MOV, right? But if you are guaranteed or you are sure that there's gonna be no collisions, right, along the path for a robot, right? But personally, I recommend you to use MVS, right? So now, now let's say I'm trying to move to this workpiece, right, to grab this workpiece, right? So now, my first move, right, I'm gonna move straight to the workpiece, right? So I'm just gonna say first MVS, right, to that position here, it's P1, right? So I'm gonna MVS to P1 at a maintain position of -30, right? And then I'm gonna so now so after let's say you are done compiling your code, you want to test it, right? You compile, right? And then you say yes, right? And then to to ensure that your code is successfully running, right, you have to see one project successful, right? So I'm just gonna so now when you are running your code, make sure towards the end of your code, right, you have typed like end, right? And then I'm gonna compile, right? So there's something wrong with my code. So okay, sure. Okay, so let me try and troubleshoot what's wrong with my code. Okay, so now, like after you are done writing this code, right? Let's say now I want to move to here to collect the workpiece, right? So you already have defined this position as P1, right? So as I said, like I'm gonna do an MVS to P1, right? like, so now I want to maintain a height, like with a height of 8 minus 8, right? So now if I go to programming, then I compile, and then now you can see it's one project successful, right? So now I can just, okay, so yeah, I can just now, if I play, as you can see, so now it moves to to the workpiece, right? But as you can see, like, moves like at a height of 30 centimeters or 30 inches or whatever units they're using here above the workpiece, right? But if I said, like, M MVO to P1, right? And then I compile, right? So now I reset play, right? And then now I insert the workpiece. So as you can see, it's moving straight to what you call, to P1 straight, right? So you can use what you call, so if there are no like obstructions along the way, you can use MOV, right? And then, but like, in, like, as we move closer to this side, right, you'll see the need for you to use MVS, right? So for example, right, let's say now you are trying to move from here to the assembly bulk, right? As you can see from here, like, you can't just use you can't use MOV. Now MOV will take, so if I can just say, now let's say I've grabbed the workpiece, right? Then I do an MOV. So we need to, before we continue, right? So as they said, like, the workpiece needs to move to the slot number 1, right? And slot number 2, right? So I want us to define these positions, right? Before we can continue, right? So here in the guide, right, I've already, like, put in these positions, right? Mhm. So here, right, I've already defined these positions, right? So the assembly bulk is defined by this position, right? So now, like, these positions, for position number 2, the first assembly bulk, it's 392. So this is your X, this is your Y, this is your Z. So I'm gonna type this in like this, just do a split screen, right? And then I'm gonna call my teach in, right? And then my positions list, right? So I'm gonna say, for position number 2, right, which is the first, I'm gonna say 372.6, right? So I'm just doing this to preserve time, right? But you can also move to the coordinates as I showed you how to, right? So this one is 14.7, and then this is 182.6, right? And then, so now if I go back here, right, to the robot, right, and then if, let's say, I were to apply this position, so if I say apply, right, as you can see, it's moving to that position right here, to drop the workpiece, right? So here, so it's moving here to drop the workpiece, right? So this is the first assembly bulk, right? But as you can see, it's not at the proper height, right? So which means now, like, I also need to modify, like, these angles, right? So under your orientation here, right? So you're gonna get your 179, 122, right? So as you can see from here, to ensure, like, if you look at this for position number 2, right? We're in position number 2, like, your 179, right here, it's coming first, right? But when you input it here, you have to input it as last, right? And then your 122, right, it's coming in last, but when you come here, you have to put it in first, right? And then you apply this position, right? And then, so now, again, so now you can see, so now for us to see that like it properly aligns the workpiece, we have to ensure that we grab the workpiece, right? So I'm just gonna go to my close the gripper, right? And then I'm gonna put that position as again as 3 point, is it 372.6 0.6, right? And then the second one is the Y, it's 14.7.7, and then my Z is 182.6, right? So it's 182.6, right? And then make sure that your gripper is closed, right? So that the workpiece is gripped, right? And then you apply this position, right? So now you saw like it moved to this position with the workpiece, right? So now we have to make sure that it's properly aligned, right? So as you can see, like the alignment of the workpiece, as you can see, it's good, right? So now you save this position, right? So this is the second position we'll be using, right? So if I can just, let me adjust it like a little bit, right? Okay. So yeah, this is perfect, right? This is perfect, right? So we'll save this as our position for the first assembly bulk, right? So where the workpiece will be tested, right? So yeah, so we'll save this second position. So I'll come here, right? And then I'll go to my positions list, right? And then I'll insert a position, right? And then after I insert this, I'm gonna go to properties, and then I'm gonna label this position as position number 2, which I will call material testing, right? Material testing slash or assembly bulk. Oh yeah, let's just call this assembly bulk, right? Assembly bulk slot 1, right? So yeah, this will be my slot 1, right? And then I save this position, right? So now as you can see, it's saved, right? So what I was trying to say here, it's slot 1, right? So this position is now saved, right? And then the second position that I want us to save as well, it's because here they said, okay, so yeah, so now like as like exercise number 1 like was stating, right? Like we need to move to put 2 positions, right? So we need to move to 3 positions at trial, right? So we need to move to the assembly block, right? Which is P2, like as I just defined, right? And then now we need to sense the material type, right? Which means we need to move to this position here, P3, where we can test the workpiece, right? So now we input these coordinates, right? So the first one, it's gonna be, so we go to our teach in, right? Position is gonna be 336.6, right? And then it's gonna be 28 0.6, right? And then that one is gonna be 174.6, right? So it's 174.6, right? And then I apply, right? And then now I input my angles, right? So my first angle here for P3, as you can see, it's 179, right? So here it's first, right? But when I input it here, right, it's gonna come last, right? So it's gonna be 179, right? So it's perfect here at last, right? And then the first one, this one, the last one, 158, it's the last here, right? But when I input it here, it will be the first, right? So I'll come here under R and then I'll say 158, right? And then I apply, right? So at this position, this is where the workpiece is tested, like for material composition, right? So the center here, right? So this center here, so the robot should move aside so that like the center has enough time to determine the composition of the center, right? And plus, like at this position, the grip of the robot is pressing the center to make sure that the center is activated to sense, right? And then from then on, right, we have to move to slot number 2, right? So our slot number 2, it's P5, right? So our P5, so our P5, or in this case, right? So since here in on our CIROS, right, with regards to positions, right, we have P1, P2. So some of the positions have been cancelled here. So I'm gonna name my test slot as P3, right? Which is this position. I'm gonna insert this position here, right? And then I'm gonna go to properties, right? And then I'm gonna call this P3, right? And then I'm gonna call this position that test workpiece material composition, right? So this is where I'm gonna test my workpiece composition, right? So that like the sensor can decide whether the material is the black one or the silver one, right? And then the next position, right, it's slot number 2, right? So this is where the workpiece ends up, right? It ends up on slot number 2, right? So I'm gonna define slot number 2, right? So in this case, our slot number 2 here, it's this one is P6, right? But since we've cancelled this one, and then this one is P4, this is going to be P5, right? So I label this 437.6, 437.6, and then minus 18.2, 171.6, right? So this is 171.6, and then my angles is 180 and 180, right? So I'm just gonna name this 180, 180, right? So this is slot number 2. As you can see, now the workpiece is gonna move to slot number 2, right? Which is this slot right here, right? So we also save this slot as slot number 2. So insert this position, right? And then you go to properties and then you label it P5. P5, right? And then I'm gonna call, is it P5 or P4? Yes, this is gonna be P4, right? P4. Yes, P4. So I'm gonna call it P4, and then I'm gonna call it assembly bulk slot number 2, right? So now I think I have defined all of the positions I need to move my robot to follow the instructions, right? So now to make sure that I see everything properly, right? So, or that I see everything like in the right format, right? So I just go to window, right? And then I press tile vertically, right? So now I can see all of the things at once, right? But now I'm going to minimize the positions list, right? Because let's not minimize it actually, right? Because we'll be using it. Okay. And then this is where we'll be writing our code, right? So let me just expand this here, and then expand this, and then expand this, and then rotate. So now I reset to ensure that I write my code right. And then now I insert my workpiece, right? Okay, let me just reset. And then, yeah, let's just wait for. So now, as I said, so now your robot now, it has to go to move to collect the workpiece, right? So now I have to do, so since there are no obstacles between here and here, right? I can just do like, so before the robot moves, the gripper opens, right? So before it moves, right, I don't want the robot to move immediately, right? So it's also important to add delays when you are programming so a robot doesn't move in extremely fast motions, right? So I'm just gonna delay for 2 seconds, right? And then after that, I'm gonna do an MOV to P1, right? So MOV to P1, right? And then I'm gonna go here and then I'm gonna compile my code, right? So to ensure that your code has been successfully compiled, the completion has to say 0 error, 0 warnings, and one project is successful, right? And then after that, like I'm gonna press play, right? And then as you can see, without the workpiece, the robot is not moving. But as soon as I insert the workpiece, robot delays for 2 seconds, and then it moves to take the workpiece, right? So now once it's here, right? So one thing also important is that you have to write n at the very, very end of your code, right? So now here, you are going to comment what you're doing. You're going to say moving to collect the workpiece, right? So it's very important to comment in what you are doing, right? And then after here, right? So it's now we are sure that we are at this position, right? So now before the robot moves out, right, it has to grip the workpiece, right? So now to grip the workpiece, right, we have to now close the grip, right? So if you still remember here, we opened it, right? So now I'm gonna say, so how to close the grip? You're gonna say H close, right? H close 1, right? So now the gripper would close, right? And then after, so you comment here, you're gonna say closing the gripper to collect the workpiece, right? And then you're gonna delay for 2 seconds again, right? And then after you delay for 2 seconds, right now, so now here, back again, like back to the instructions, right? They are saying like after the robot grasps the workpiece, right? It moves to like to detect the material, right? And then which means the robot has to now move to the first assembly bulk where the material composition will be detected, right? So now how you do that is that now you say, so let's say here at the top, at the very top, right? I want you to comment that you're saying here you're collecting the workpiece, right? So this is what the sequence of steps like meant, right? So now, as I said, like, so here, since your robot takes the shortest path, right, to move to the assembly bulk, right, as you can see here, if it just moves shortest path, it will just move straight, and then it will collide with this as well as with this, right? So we have to move it up, right, before we go. So we do an MVS now, right, to a certain height, right? So we say MVS at the same at P1, right? So we want it to move straight up, right, at P1, right? So MVS at P1 minus state, right? And then now I'm gonna reset, right? And then I'm gonna move to this position here, right? And then I'm gonna compile my code. So project successful, and then I'm gonna play. So now, as you can see, instead of it moving straight to the assembly bulk one, right, I want to ensure that like it doesn't obstruct with anything. So it has, the robot has to go up like to the proper height, right, before we move it to back to the assembly bulk, right? So now from here, right, we define some new moves, right? So here I'm gonna say we are moving to the assembly bulk, right, slot one, right? So now, before, as I said, before we move, right? So now, so now we do moving to the slot one, we do an MVS again, MVS to, now we're doing an MVS to P2, right? At minus state, right? So we want to do a movement like to P2, right? But it won't go to P2. Instead, it will move to P2 at this height, which means it will be in position number 2 at a height of minus state above P2, right? And then from then on, so I can just here, like before, I can also delay by 2 seconds here, right? And then delay here, right? And then now I want to move directly to P2. So I say MOV to P2, right? And then here you're gonna say, gonna comment this as horizontal motion, to slot one on the assembly bulk. Right, and then here you're gonna say move into slot one, right? So now we're moving directly into slot one, right? So now I compile my code again, right? And then I reset, right? And then I press play. And then now I insert the workpiece. So now as you can see, it moves, grabs the workpiece, delays 2 seconds, goes up, and then goes to assembly part. So this is the MOV, that move. And then the one that was performed last, where the robot moved straight downwards, that was the effect of the MOV move, right? So now, like, let's say you want to see like which part of the code your thing is executing, right? So you go to project management, right? And then you go to here, right? And then you compile, right? And then now if I can run my code now, right, I'm gonna press play, right? So now as you can see, so now while there's no path, like the robot is trapped in this while loop, right? And then the moment I set the workpiece, which means the moment that part AV becomes what, the loop breaks, right? And then starts executing this part, right? So robot now is moving to P1, right? And then grippers closing, and then delay, and then MOV, you saw MVS, right? And then it's moving to P2, right? So now, after here, right, the robot has to the robot now we are trying to test the workpiece, right? So now the robot has to move out of its position to ensure that the workpiece is given enough time to test, right? Which means we need to move to position number 3, right? Where like it will allow the workpiece to be tested, right? So now I comment here, right? Then I'm gonna say moving the workpiece to, can I call this, to testing, or moving to the, let's say moving to the testing position, to the testing position, right? And then testing position, right? So now after the robot has placed the workpiece, it has to let it go, right? So we delay for 2 seconds, right? And then our gripper has to open, so the robot releases the workpiece. So we say H open 1, right? And then delay 2 seconds, right? And then after delaying 2 seconds, right? So now I want to move to the testing position, right? So the testing position, still remember, it's somewhere here, right? Which means we need to move the robot up, right? So we do MVS at position number, we're on position number 2, right? And then we move to the height of -8, right? And then we delay for 2 seconds, right? And then now I compile my code. After I compile my code, now I can run it, right? So I have to reset first and then press play, right? And then insert the workpiece. So now I'm moving to, now I move to the testing position, right? So testing position is position number 3, right? So as I've moved up, like from here, right? From MVS position number 2, right? So I move to an MVS again to position number 3, right? At a maintained height of -8, which means it will move horizontal, right? And then now, like after I reach this position, I delay for 2 seconds. Then now I do move directly into position number 3, right? So you also comment on what you are, I want you to comment on everything that you are doing, right? So you'll comment here, and then comment here, right? And then now, so here, let's say, for example, I'm gonna say upward movement to a height of 30, right? Above, or above, above the P2, above slot 1, right? So moving 30 whatever units up above slot 1, right? And then here we're doing a move horizontal move to the testing point, right? But but we're at a height of 30 units as well, right? Above the testing points, right? And then here we're moving directly into the testing point, right? And then now I compile my code. Come on. right? So now after testing, right? So after testing here, right? So now here, this is where you can analyze your inputs, whether they're turning on or off, right? So here, let's say, so it's not important. So let's say we're looking for the B1 underscore R sensor, right? Which is it, yeah, B1 underscore R, right? Which is, let me just confirm, it's B1 underscore R, okay? So let me just look for it here. So as you can see now, like since it's detecting the metal workpiece, right? It's currently true, right? And then if it detects, let's say I were to input, as you can see now, it's not detecting workpiece, it becomes false, right? So let me say I was to input a black workpiece, right? You will see, like, since it will detect a different material, the black workpiece, it won't turn on, right? Yes. So now you can see that the robot is not, the sensor is not turning on, right? Because it's, so now you can conclude that, like, when the robot detects, like, the, if like the workpiece is made of metal, for example, or the red workpiece, it turns on, right? But the other one, it doesn't trigger the sensor, right? So let's say I will now now I will to put in the yellow workpiece. So now this sense here, it should get triggered. So now, as you can see, it becomes true when the robot moves to the testing position, which means it, the workpiece detected, like, it's of silver, right? So, like, write that down somewhere, keep that in mind, that the B1 underscore R sensor, it turns on when it detects, when it detects a when it detects a workpiece, like a metallic workpiece, right? That's the only time when it detects the black workpiece, it doesn't get triggered, it remains to be zero or false, right? Okay. So now I close my code by mistake, but I can open it, right? And then, so now after moving to the testing point, right? So after moving to the testing point, right, the robot, it takes the workpiece again, right? And then it moves to the second slot, right? So now we have to write a code, right? To take the workpiece from, to grasp the workpiece again from here, right? So now we can, as you see from here, as you can see from here, right, we can't do an MVS move because it will collide with the robot. So the robot has to move up first, right? So before I write that, so I'm just gonna comment taking the workpiece from the slot one assembly bulk, right? So now first, right, to avoid collision, I have to do an MVS straight on position number 3, right, at a height of -8, right? So the robot can move slightly up, right? So if I compile this, so now if I reset and then insert the workpiece, so now I want you to, like, observe like when it gets to this move, right? So just to ensure, as you can see, like it moves straight up, right? But that was too fast. Like I'd like to add a delay here, right, for 2 seconds, right? And then like moving on, right? So now after moving on to this height, we delay for 2 seconds again, and then we do an MVS. Now I want to do a horizontal move back to position like 30 at 30 units above position number 2, right? So we do an MVS to P2, right, at minus 30, right? So now, and then I delay for 2 seconds, right? So now if I compile this, so now I have to now, after delaying for 2 seconds, I'm gonna do an MOV straight now to position number 2, right? And then I'm gonna delay for 2 seconds, right? And then like after that, like since now I've reached position 2, I'm gonna tell the gripper to close, right? So I'm gonna H. So I'm gonna H close 1, right? And then delay for 2 seconds, right? So now just to also preserve time, like I won't be commenting. I've already showed you how to comment, right? So you'll be okay, but for the purpose of the exercise, since this introduction, that I'll comment on everything. So now here you are doing an upward move from the testing port, right? To date, right? And then here you are doing a horizontal move to slot 1, right? And then here you're moving in to slot 1, right? To grasp the workpiece, right? And then here you are closing the gripper so you can grasp the workpiece, right? And then now from here, after you grasp the workpiece, right, you have to move up, right, from position number. So you do an MVS again to, so now, yes, yeah, you do an MVS above like position number 2, right? But since you can't move straight here, you like since the, as you can see, the workpiece it's inside the assembly bulk here, right? So if you just move straight using MOV, it will create an obstruction within here. So you have to move the workpiece up to minus 30, right? And then you delay for 2 seconds, right? And then you do an MVS to slot number 2, right? Our slot number 2 is position number 4, right? So you do to P4 at a height of minus 30, right? And then when you get there, so now let me just compile this again so I can show you how the program runs, right? And then you reset, and then So now we are here on position number, on the slot number 2, right? So after we reach slot number 2, right, we have to move directly down. So we do an MOV to pin number 4, right? So first, we always delay as well, let's say by 2 seconds, right? And then now, after we have reached this slot, right, obviously we want to let go of the workpiece, right? So you will delay for 2 seconds, right? And then you'll open the gripper so the robot can let go of the workpiece, right? So you'll delay for 2 seconds and then you'll do an H open, right? So it's H open 1, right? And then you will compile your code, right? And then now project is successful. So now if I just run this code, so now as you can see, like since there's no workpiece being detected, which means the part available sensor, it's 0 or it's false, right? The robot is trapped in this while loop, right? Up until I insert a workpiece, which whereby now the part AV becomes 1. That's when this loop is broken, and then the robot will execute this code. So now, after we have reached this position, right, now we have to return our robot to our home position, the one that I talked about, P100, right, so that the robot awaits the next sequence, right? So from here, right, how we move it back, right, so we delay for 2 seconds, right, and then we do an MVS, right, at this position at P4, right? So we move the robot slightly up so it doesn't collide with anything, right? So we say MVS P4 to a height of -30, right? And then before it moves to back to home, we delay, right? And we delay by 2 seconds, right? And then from now on, like we are sure that there's no obstacle between the robot when it's at this height to when it returns to home. So we just do and MOV back to home, right? Our home, which is here, we defined it as P100, right? So we do an MOV back to P100. And then like always ensure that like at the end of your code, there is end, right? And then now I compile, right? And then I reset and then I press play. So the robot is trapped in the loop, and then inserting a workpiece breaks that loop and then it starts executing. So now, as you can see, it's moving back to our home position by 2 hours. So now, since like this work cycle is complete, right, it's moving back to the home position where it's gonna await the next work piece that comes, and then it can start the cycle again. So that's your exercise number 1, right? So in the next video, we'll be doing exercise number 2 and 3, right? But yeah, so yeah, thank you for watching. Don't forget to subscribe and like, right? And also tell your friends.